Preparation of metallographic samples for brazed joints of pure copper liquid cooling heat sink. In the age of artificial intelligence, the power consumption of AI chips continues to rise. Its computing power center generates a lot of heat during operation. To ensure that the chip maintains fast response and stable output, efficient heat dissipation has become a core engineering challenge. Liquid cooling technology came into being. Cryogenic liquid flows through the surface of the AI chip at close range. After absorbing heat, it is circulated to the outside through a closed pipeline for release, reflow, and reuse after cooling. The solution relies on the liquid's superior thermal conductivity, effectively solves the heat dissipation problem of high-power AI chips. One of the key manufacturing processes of liquid-cooled heat dissipation plate is pure copper brazing. The welding quality directly determines the sealing of the heat dissipation plate, thermal conductivity, and long-term service reliability. This video will analyze a brazed, pure, copper liquid-cooled heat dissipation plate, standardized metallographic sample preparation, to evaluate the microscopic quality of the welded part. Cutting. We cut and sample using automatic metallographic cutting machine with S20 silicon carbide grinding wheel cutting blade. Accurate interception of welding parts of pure copper heat dissipation plate samples. Adequate cooling is required during cutting. Avoid structural changes of pure copper due to local overheating or thermal damage to brazed joints. Mounting. Clean the surface of the cut sample. After removing oil and debris, put it into the silicone mold. Select TJ2568 epoxy resin with excellent edge protection for cold inlay. Weigh resin and curing agent accurately by weight ratio. Stir well and pour into the mold. Then the mold is placed in a pressure-cooled mosaic machine to solidify under pressure. This operation can effectively eliminate bubbles inside the resin. Obtain high-transparency mounting blocks. It is convenient for real-time observation of subsequent grinding and polishing processes. Grinding and polishing. Preparation of mirror surface by quasi 4-step method. Step 1. P400 silicon carbide sandpaper. Quickly flatten the sample surface to eliminate cutting damage. This is the scratch left by the P400 sandpaper. The second step is polishing Buga 9-micron polycrystalline diamond polishing solution. Remove coarse abrasion marks and initially reduce the deformation layer. This is the scratched state left by the 9-micron diamond. Step 3. SC polishing Buda 3-micron polycrystalline diamond polishing solution. Refine the surface to further eliminate scratches. This is the scratched state left by the 3-micron diamond. Step 4. ZN polishing Buda 50nm silica polishing solution. Final fine polishing, removing fine scratches and obtaining a scratch-free mirror surface. Thorough cleaning is required between each step. Prevent coarse particles from being carried into the next process. Ensure the finish of the final viewing surface. This is the state of 50 nanometer silica after polishing. Observation. The completed sample will be prepared, observed under a metallographic microscope. The gap of the brazed joint can be clearly observed. The ideal clearance range is typically 10 to 100 micrometers. Too small a gap can impede capillary filling of liquid solder. The gap is too large. This results in inadequate filling or the formation of holes. Both will significantly reduce joint strength. Pure copper brazing is extremely sensitive to surface quality before welding. Before welding, it is necessary to strictly perform ultrasonic degreasing to remove oil stains. Then remove the surface oxide film by pickling. If there is an oxide layer on the surface, liquid solder metal will not wet the base metal. Formation of large areas of non-penetrating defects. During long-term hot and cold cycle service, such defects will directly evolve into leakage channels, cause the heatsink to fail. Therefore, metallographic analysis is not only the core means of welding quality evaluation, it is also a direct verification of the validity of pre-treatment and brazing process parameters.
Trojan. Discover the truth of material.